Good day, I'm Maile Madziba. Welcome back to our channel. It's been a while. Today we're beginning with our classes or lessons for CIR123, which is the second chemical engineering module at the University of Pretoria. Like I mentioned earlier, I'm struggling to find some resources or some material to actually create content to upload on YouTube. So I would appreciate if anybody who has the CIR123 study guide to email it to me, maybe in PDF, or take it pictures and email it to me. That will really be appreciated. I will leave my email in the comment section and I will appreciate to do that. My desire is that I upload a video for CIR123 every single day, but that depends on me getting that CIR123 study guide. So today I'm having class test 1 of the 2011 module, or the 2011 CIR123 module at the University of Pretoria. Interestingly, this is actually the class test that I wrote 11 years ago when I was a student, or when I was a CIR123 student at the University of Pretoria. So with that said, we'll go straight to the question. It says, nitrogen, which is 42 kilograms, and hydrogen, which is 6 kilograms, are loaded into a batch reactor and heated so that the following reaction takes place. NH2 plus 3H2 equals to 2NH3. Now it goes further to give the information that the reactants and products are gaseous. So it says the reactants and the products are gaseous. It goes further to say the reactor is tightly sealed so that no gas escapes. So with that said, the question is calculate the percentage access reactant. So this is actually A of the first question. As time goes by, or next time I will upload B of the question. I'll keep uploading this class test in parts. So now they say calculate the percentage access reactant. Now look, taking into consideration the 42 kilograms and the 6 kilograms of the nitrogen and hydrogen respectively, it's not so easy to first tell which one is the limiting reactant and which one is the access reactant. And remember, for us to calculate the access reactant, the first thing we need to know that which one is the access reactant and which one is the limiting reactant. And we can't do that with it's not so easy rather to do that just by looking at the masses. So what we're going to need to do is to calculate the number of moles of each nitrogen based on the masses given, and also use the reaction equation to actually decide or to calculate or find out which one is the limiting reactant and which one is the access reactant. And now calculating the number of moles of nitrogen. We have number of moles of nitrogen equals to 42 kilograms all over the molar mass of nitrogen. The molar mass of N2 is 28 kilograms per kilomole, right? And if you use your calculator, that gives you 1.5 kilomole, right? And that is actually our N2. Now going further, calculating the number of moles of H2, it gives us 6 kilograms all over. The molar mass of H2 is actually 2 kilograms per kilomole. And with that said, then if you use your calculator, it gives you 3 kilomole. Now there's something I want to highlight here, that how do we then know which one is the limiting reactant and which one is the access reactant? Now looking at the equation, you can actually notice that when you have 3 moles of hydrogen, you're going to actually need 1 mole of nitrogen. Now when you look at the equation, when you look at what we have given, we realize that we have 3 kilomole of hydrogen, but then we have 1.5 kilomole of nitrogen. That tells us that the nitrogen is more, because the ratio of the equation says for 3 kilomole hydrogen, or for 3 kilomole hydrogen, you need 1 kilomole of nitrogen. So if we have 3 kilomole of hydrogen, we would have expected to have 1 kilomole of nitrogen, but then we have 1.5 kilomole of nitrogen. That then tells us that the nitrogen is actually in excess, and the H2, or rather the hydrogen, is then limiting. So moving further, then we're going to make sure that we calculate. I just want us to calculate something. Remember, now that we have decided that this is actually the access reactant, we're going to then need to calculate a couple of things so that we can actually make up an equation to calculate or to answer the question that says the percentage access. Another thing I want us to calculate now is the theoretically required. Remember that the equation says the ratio of nitrogen and hydrogen is 3:1, like I mentioned, and we have 3 kilomole of hydrogen. So that means that how much do we need theoretically to actually react all of the hydrogen, which is actually the lesser one, or the limiting reactant? According to the equation, it's actually 1 kilomole. So let me just write here NB, N2 theoretically required equals to 1 kilomole. Right, yeah, that's very much important. So now we know that theoretically required N2 is actually 1 kilomole. However, we have 1.5 kilomole, which makes the N2 then which makes the N2 an access reactant. So with that said, that takes us then to our equation. So we can just say percentage access is equals to total kilomole, let me just write access reactant. This is the general equation. Total kilomole access reactant minus the kilomole that are theoretically required. The kilomole of the theoretically required is still access reactant. That is access reactant. So is the total kilomole of the access reactant minus the kilomole of the theoretically required access reactant all over the kilomole theoretically, or should I say, let me say theoretically required kilomole. Yeah, it sounds better. Theoretically required kilomole of the access reactant. Yeah. Let me also fix here. Let me say kilomole. I hope it's visible. I hope it's visible, but because I'm explaining it, I think it will be better. So now everything else, sorry for that, I'm lacking space. Everything else you multiplied it by 100%. Yeah. So with that said, so now when you move further, we know the total kilomole of the access reactant. Firstly, we know that the access reactant is nitrogen. We figured that out. And we know the total kilomole of the nitrogen is equals to how much? Or should I? So let me just write it. Let me just add an additional step. Total kilomole nitrogen minus theoretically required nitrogen, right? All over theoretically required nitrogen, everything else multiplied by 100%. I just added an additional step so that to explain this first step that appeared to me as a little bit complicated because of the lack of space, but I think if one gets confused in the first step, when they come here, they will actually get to understand what was happening there. So now that is what is it now. What we do now is just to substitute the values. So we say percentage access is equals to the total kilomole of nitrogen. We've calculated the total kilomole of nitrogen to be 1.5 kilomole. It's 1.5 kilomole minus the theoretically required nitrogen. We already figured out that the theoretically required nitrogen is 1 kilomole. We found it out using the chemical equation and the limiting reactant. So we know that it's 1 kilomole. And then all over here, we still have theoretically required nitrogen. So we know it's still also 1 kilomole multiplied by 100%. Now when you use your calculator here, it should give you 50%. 50% access N2. So that is actually how to answer this question, that calculate the percentage access reactant. So thank you for your time. I hope we meet again in our next video.